Hi, I'm Ben, and I'm a tech consultant at IBM. All views and opinions expressed here are my own. So I'd like to talk about something called CI/CD. This is one of the core principles of DevOps and stands for continuous integration, continuous deployment. It can also refer to continuous integration, continuous delivery, which is something slightly different, but the general approach is similar. I'll come back to this distinction in a moment. There's a lot of content online that seems to give contradictory definitions of the two. The definition I tend to follow is one laid out by Eric Minnick in an IBM Cloud video called Continuous Deployment versus Continuous Delivery. It's very good and I'd recommend checking it out. So in a sentence, CI/CD is all about getting newly written code into your production system quickly and safely, with a real focus on little and often. This is in contrast to making large changes on an infrequent basis, where we can expect to run into high numbers of unforeseen issues. Continuous integration means frequently checking new code changes don't cause an issue with our code base, that the application can still successfully build, and a series of automated tests pass. This should be an automated process that kicks off when developers add new changes to the central code base. Continuous deployment is where we take any new changes, run an extensive series of tests against those changes, and then get new code running in our production environment. This should also be an automated process. Continuous delivery comes into play when we need to add human checks into this process before any code gets deployed. This might be because we don't have a mature enough set of testing processes, or possibly the implications of bugs in our production system are simply too great to rely on a fully automated process. I see this as production-ready features being continuously delivered by the developer team and awaiting human approval before then being subsequently deployed. CI/CD is a simple idea, but it's really powerful. A development team dedicated to following this principle will be able to enjoy an easy deployment process and see a high rate of output when it comes to getting new features to customers. If you're continuously producing small changes and getting them into production, you'll have a much better feedback loop on what worked well and what could be better. This way of working allows you to design in an agile way and produce a higher standard of product. Everyone wins. It's worth saying at this point that CI/CD isn't a single tool or one way of doing things. As with the other DevOps principles, it's an ideal, and there are a number of ways of working towards it. I'll touch on potential implementations as we go, but it's worth keeping in mind that there is not one strict recipe for how to do it. The important thing to take away from this video is the ability to know what CI/CD is at a high level, regardless of tooling, and why it would be beneficial for a software development team to use. The best way to see the value of CI/CD is to imagine two different teams working on a similar product, one following a more traditional software development cycle, and the other following CI/CD. Both teams are working on a microservice for their company, which a lot of other services within the company rely on. Their goals are to improve performance and add functionality. This is an abstract example, so we're not going to get stuck in the weeds with what they're coding. Both teams are using Git. This is something worth focusing on for a minute. Git is a software version control tool, and if you're watching this video, the chances are you've already heard of it and have probably got some experience using it. But just in case you haven't, it's a tool that allows multiple people to edit a codebase at the same time and helps manage these changes. Imagine you're in a team working on the same text file at the same time from different computers. How do you handle everyone making changes? Does everyone have a copy on their machine? Do you agree who changes that? How do you all merge the changes back together? What if two people change the same thing? Managing code changes in a team can be even more challenging, and if the changes aren't compatible, it can break the code. Git helps with all of this. The first thing Git does is keep a history of all changes that have been made to the code, and you have the option of going back to any one of these changes if you encounter an issue. These changes are known as commits. The second thing Git does is it allows you to create your own version of the code to work on and keep separate from everyone else's changes. This is called a branch. When you're ready, Git merges everyone else's changes into your branch, or merges your branch back into the main branch, adding in the changes you've made. Now, Git is sometimes referred to as a CI/CD tool, which is a bit misleading, as Git, or another version control tool, is essential for CI/CD, but just the fact of using it does not mean you're doing CI/CD. And this brings us back to that distinction between tools and principles and methods. It's not so much what you're using, but actually what you're doing with those tools. Okay, so back to our example of the two teams. In our non-CI/CD team, one of the developers has been working on several changes on a branch over the last month and is ready to merge them back into the main branch. It's at this point that they find they have hundreds of merge conflicts with the main branch due to changes others in their team have made. This means that their changes can't cleanly slot back into the main branch as they'd be overwriting someone else's code, or potentially even the file structure has changed so that the place their code was going to go doesn't even exist anymore. This situation is affectionately known as merge hell. Fixing it takes a lot of time, and fixing it incorrectly will result in broken code, a very real possibility. So after they've finally sorted out these issues, they now need to build and test their code to check it's ready to be deployed to their production environment. Straight away, they find that they have issues building the code. These changes that they've made break when run alongside the changes others in their team have made. So now a large amount of code has to be fixed as large changes have been made. After this is fixed and the application builds, they can run some tests. It's now that they find out that a supporting internal service changed its API a month ago and no one was aware of that fact. So this means they've got to change a significant amount of their code again in order to interact properly with this new API. Then they have to repeat the whole process. You can see where I'm going with this. When that's finally sorted, they're ready to deploy to production. It's a bit rushed as the last minute issues meant they missed some business driven deadlines. They're deploying a massive change and it's the first deployment they've made in a year. They've had to edit their cloud infrastructure to accommodate this change, as well as adding in a number of third-party services, the production accounts for which they'll be connecting to for the first time when this software goes live. After all the last-minute fixes to their code, they're not feeling confident given how many changes they will be making to their production environment and the fact that they're relying on everything working perfectly. This is not an enjoyable way to work for anyone involved in this process. So now we can look at our CI/CD team. One of their developers created a feature branch yesterday and started making changes to it. In the spirit of little and often, their features are small, achievable bits of functionality that form part of a bigger picture. This developer finished their feature today, raised a pull request to merge it back to the main branch, the central code base, and found they had no merge conflicts. Happy days. This then triggered an automated application build using a pipeline. A pipeline is a pre-coded set of steps run on a server. There are lots of different pipeline tools, so we're not going to get into it anymore in this video. All you need to know is it's an automated process run on a server that usually handles building, testing, and deploying an application. The developer was unlucky and had a small issue in their code, so the build failed. But small change, small fix, and because this prevented merging into the main branch, it didn't affect the rest of their team. They fixed the code, the application built successfully this time, and now their changes are merged into the main branch. This kicks off a pipeline to deploy these changes into their test environments, and a suite of automated tests are run against it. Once these tests pass, their code gets deployed into production automatically using a canary deployment. A canary deployment is when only a small percentage of user traffic initially sees these changes. If everything works, the changes get rolled out to everyone, and if there's an issue, the changes get rolled back automatically. In summary, our developer made a small change, was alerted immediately of an issue, fixed it, and then upon their change passing the tests, it got deployed immediately to the end user. For the CI/CD team, the changes are small, the errors are small, and the fixes are small. For the non-CI/CD team, the errors can be built on top of errors across loads of changes, so the process of fixing them is not a clear one and can mean fixing code that no one has touched in weeks or possibly even months. Obviously, these are made up examples, but I think you can see how it rings true. Small changes mean small fixes and low risk. Large complex changes mean large complex fixes and high risk. The whole principle is, if we do our production deployments as often as we possibly can, with as much of an automated process as possible, we dramatically reduce the number of unknown variables, inefficiencies, and inherent risk within each deployment. The practice of doing this also forces us to create a super smooth deployment process. CI/CD benefits both the developer team as they're able to enjoy a far more pleasant and satisfying workflow, but it also benefits the business and customer as frequent small feature updates allow for continuous assessment of product performance and customer needs. The feature backlog can be easily reprioritized according to this assessment, and the end result is a better product. So, in summary, continuous integration, checking the new code change fits in with existing code and doesn't break anything. Continuous deployment, once it's been tested, get it deployed to production. Everything is being done little and often. We achieve this workflow with a combination of version control tools such as Git, task automation pipelines such as Jenkins or Tekton, and testing tools such as Jest. One thing I should now point out is that in practice, CI/CD can be a bit of a spectrum. It's an ideal to aim for, but the journey to fully embracing it might be a series of smaller stepping stones. CI/CD purists might have a fully automated system after a pull request goes through. If all code passes, then this gets automatically deployed into production, no questions asked. But to do this, you need real confidence in your testing suite, your practices around keeping it updated, and your automatic rollback capabilities if something goes wrong. Some teams with mission-critical software might introduce a series of human checks before any changes go live. There's also no set answer for how little and how often. You should be trying to push for more frequent deployments until you find the sweet spot for your team. In a way, it's like trying to keep your house tidy. Deploying to production is always a little bit stressful. Might not be much stress, but it's always something. Kind of like tidying up. A little bit of mess is easy to sort out, but sometimes it's easy to put it off too. But if you put it off for too long, it becomes a big issue. The same as if you put off a lot of changes to deploy. It becomes far more effort to sort out compared to if you just stayed on top of deploying small changes every time they were ready. So hopefully this video has given you enough info to know what CI/CD is and why it's useful. The next step is looking at ways of implementing it in more detail.